In this video, we're going to go over some of the core prompt engineering techniques. There's so much active research going on here. There's literally almost new techniques every week, but these are the core ones that have really stood the test of time, I would say, over the last few years. So we're going to have some fun in this video. Now, why do we even have prompt engineering? Well, because large language models like ChatGPT, they're really big prediction machines. The way that they actually work is by learning the patterns of natural language and then being fine-tuned to answer questions for you. I show an example here. So if you have the cat and the model was going to predict what word is going to come next, the most likely common word that it's seen in its training vocabulary is hat, so the children's story. But you're going to get different answers sometimes based on a number of factors, just based on the probability of what it chose at that point. You can change the temperature setting, but all of these are based on it learning the patterns of language, which most models are going to learn the basic patterns, but then they get trained or fine-tuned, and then they also go through reinforcement learning to figure out the best way to answer your questions and solve problems. So we can't know ahead of time. It's difficult. Like, these models are so big, no one understands fully exactly how they're going to work. Therefore, you have prompt engineering, a discipline, so that we can get the most out of these models by figuring out what is the best way to ask it questions, to give it context. Those are the techniques we're going to cover right now. This first one is so critical. If you're doing a problem-solving task, or you have like specific techniques that you would go through to do that task, if you were going to do it yourself, you want to give the model an example. And in the literature, they call this a shot. So 0 shot would be you're just asking the model to do something, and it has no example that you're giving it. It's purely going to go off of its training data. Now, recent models also have tools that they can use, so they can find information on the web, on the internet. They can use other tools like calculators. They can write Python code and run that. So it's not 100% limited to pre-trained knowledge. However, it's got to figure it out. You're not telling it, okay? Now, if you look at this graph, this is an older graph, but the point is still well taken, that as soon as you give one example, the one shot, look at the graph, how the lines shoot up. And in a larger model, in this case, the 175 parameters, it is much more effective. What a huge difference. So if you can give it just one example, especially if you're working with something that is not common. So if it's like in your work domain, which might be proprietary, or it's not something that would have shown up in training data, this is how we do things, you would want to give an example. And then you can also see there's a gradual improvement if you can give more than one example. That's called few shot. Now, if you're going to know one technique, you want to know chain of thought, and you probably have already heard of this. So the idea here is that because the models are generating or using probability to figure out what tokens or words to generate next, that if you can get it to generate tokens that lead to what would be interim thought, or if you're compare this to a math class where the teacher says, show your work. And if you've got a complex math problem, rather than just writing down the answer for, how did the student get that? Especially if they got it wrong, like why did you get that answer? So chain of thought would say, show your work. And it's going to generate a lot of like kind of interim tokens that say, okay, well, the first thing I need to do is this. It breaks down the problem into steps. And then you can actually also see what kind of quote unquote reasoning the model is doing. Now, there is some research that says that models can generate interim tokens, but actually be quote unquote thinking about something else. I think that's certainly possible. Obviously, the research shows that, but I think predominantly you're going to get positive results from this, and it's going to lead to more accurate. It's going to lead to more accurate results, and especially in problem solving, math, logic, coding. This is going to be invaluable. Now, this is, I would say, the core technique. Some of the more recent models build this in, so you don't necessarily need to do this. But originally, just by adding the phrase, think step by step in a prompt like this, you would see a better performance. Now, there's a whole family of techniques that kind of build off of this. Tree of thought would say, okay, well, don't just go down one path to try to solve this problem. So if you come to a point where I could, consider option A or consider option B, kind of branch out and do both, and then see which one gets you there. Tree is just kind of doesn't have any circular. The graph of thoughts would allow for even more complex. That gets a little bit tricky because you can have circular loops, and if you're thinking about an AI agent, you don't want it to get into you don't want any system to get into a never-ending loop. A thread of thought, so sometimes you want to just make sure the model stays on the same reasoning path because it might take a while to get there, and therefore, you got to stick with it. Scratchpad is interesting. So these are prompts where you would say, you won't even tell it the problem necessarily initially. You might say, write or tell me all of the things about this topic or considerations for this issue. Have it generate all of that. Now that's in the conversation context. Then you would ask it to use that information to perform some task, answer some question, solve a problem. Self-consistency is interesting because these are probabilistic models. So have the model answer the question 8 different times. You could do that in a single prompt. You could ask it the same question multiple times. And then if you get, of those 8 responses, you get 5 of them are the same answer, more than likely that's going to be its best guess or most accurate answer. Then there's user intent. You can do different things like having the model rephrase what it just told you, or rephrase the input that you just gave it. So this kind of ties into chain of thought. It's now generating more words and tokens that restate the problem and giving it, it's all increasing the probability that the model is going to predict the right words or the right solution path that get you to your answer. And then a completely different technique here is number 3, which is generally called RAG, Retrieval Augmented Generation. And so in that case, you are instructing the model, or you have a system already programmed to do this, where when you ask questions, it's going to retrieve information from some data store using some technique to try to get relevant information. And so even if the model hasn't been trained on it or doesn't know anything about it, if you get this information and put it in the context, in the prompt, now it can reason inline and infer directly without having seen this before, and it's actually pretty effective at doing that, very effective in many cases. Now, retrieval augmented generation gets into what prompt engineering is almost evolving to become. Many people believe it's more about context engineering, meaning that the real, if you will, problem to solve is what information, can I get the best information, the most relevant to put in the prompt or in the model's context so that it can answer a given question. Now, if you don't provide it specific information, again, it's going to rely on its training, whatever training data it had, or the tools that it uses to search the web. If you search the web, you know how that goes. You may not always get exactly what you want. So the better job you can do of providing context. Again, this is all about improving the probability that you're going to get the right tokens and the right answer. So in a future video, I'm going to talk about context engineering, which is a hot topic now, very, very important. And part of this is because the models are improving. So some of these prompting techniques, like I said, chain of thought, in some models are actually built into the model, and you will see you can turn on or off, for example, I think on Google Gemini, whether to show the thinking tokens that are happening or whether you just want to see the end answer. That depends on whether you care how the model arrived at that answer, which in higher stakes scenarios, you really care. If you were talking about a healthcare scenario or a financial decision or guidance, you definitely want to know. If you're asking for what are some good TV shows I can watch, maybe you don't care so much. And then a real quick summary here. So chain of thought is your fundamental technique. Any kind of math, logic, problem solving, you're going to want to involve that and look at what is the model thinking about as it arrives at the answer. Retrieval augmented generation, we just covered. Context engineering is really going to be the key there. And then if it's something that requires examples, or I should say in the chain of thought, there's one other key topic that if you have specific steps you want the model to follow, then tell it. Say, I want you to solve this problem. First, do step A, then do step B, and just spell out how you want the model to approach that task. That's another variation of chain of thought. And then the few shot, so even giving just one example of how you want the task or how you want the model to respond to you, consider write a poem in my style of writing. And in that case, the one shot would be given an example of your writing. And you'll see that it's pretty good at mimicking that style. If you can give more than one example, even better. It's all about improving the probability. Okay, I'm going to stop the video here. So I hope that was helpful, and I will see you in the next video.